So in order to solve this system of equations, generally speaking, we're going to make a graph and we're going to see where the two intersect. And so when we do that, we can then see that these two lines intersect at this point over here. And so then that's our solution. So that has an x-coordinate of 4 and a y-coordinate of 6. So our answer then is at 4, 6. And having solved this problem now by graphing, I want to show you that there actually is another way we can do it without graphing. So we're going to be doing more solving today, but you're not going to need graph paper for this part, although you're welcome to do it on graph paper if you wish, but line paper will work perfectly well. Have some ready to go and write down that system of equations on your paper, and we are going to walk through the process about how we can do this without relying on graphs all the time. Because those can be very helpful, but they're not perfect. Nothing is actually perfect. They all have their strengths and weaknesses. The weakness of graphing method is it can be imprecise. It can be hard to tell where they cross if it's not a nice pretty number. This method will work and tell us what they are exactly, even if they're not at nice pretty numbers. Now as you write down this system, thing to note here is notice we got that curly bracket on the left side. Yes, you do want to include that. That little bit of notation is saying that these two equations are related to each other. Without it, it's just two random equations kind of just hanging out together. Alright, so to solve this algebraically, we're going to use something called the substitution method. That ring a bell? Some of you are nodding, some of you are shaking your head. It really depends on, one, what you've seen before, and two, how well you remember it. Substitution method basically says that if I know what y equals, so for instance in this first equation y equals 2x minus 2, I can take that and plug it in for y in the other equation. I can substitute that value in. And so my first line of work for this is going to be 2x minus 2 equals negative 1/4 x plus 7. So I can set them equal to each other because I'm plugging that value in for y. And now we can solve it algebraically. So let's actually go through that algebra and actually show that. Yes, I do want to see every step. What are you doing to both sides? I'm going to go ahead and add 2 to both sides. You didn't have to start it by doing this way, but I think it's the one that makes the most sense at the start. On the left side, that just leaves me with 2x. On the right side, that leaves me with negative 1/4 x plus 9. All right, now I need to move that 1/4 x to the other side, so I'm going to add 1/4 x to both sides. Notice, yes, it's a fraction, but I'm just trying to move that x over, so I just take the whole thing as it is. Now, on the left side there, I have to do 2 plus 1/4. Okay, so what is 2 plus 1/4? There's a number of different ways we can say it. We can say 2 1/4. You could say 9/4. Or, what most people will do, and it's going to be the most comfortable for this first problem at least, we can just call it 2.25. Yep. And then on the right side that equals 9, because I haven't changed that yet. Alright, now having done that, I still need to get x by itself, so I just have one last step. How do I get rid of the 2.25? Divide, absolutely. So I'm going to divide both sides by 2.25. You're probably going to need a calculator to do this work. Go ahead and take 9 divided by 2.25, and we'll end up with x equals, and we find that x equals 4. All right. Now, remember when we did this problem the first time, you did it by graphing. Your answer was not x equals 4. Your answer to that problem was 4 comma something. How do we find the something in this case? And so that's exactly right, where we're going to take that x value and we're going to plug it in for x in one of the original equations. Now, it doesn't matter which one you plug it into, pick whichever one seems easiest. Of those original equations, the 2x minus 2 looks like it's the easiest one to work with, so there's 2x, I'm plugging the 4 in for x, minus 2. And so then we go y equals 2 times 4 is 8. 8 minus 2 is 6. And so that's how we then get the solution of 4, 6. So now we're going to take a look at solving this system. Now you notice what's a little different about this one. The top equation, I know what y equals. But in the second equation, I do not. So I cannot just set them equal to each other. But I can still use the substitution method, because substitution method just says that if I know what y equals, I can take that and plug it in for y in the other equation. So let's actually do that then. So the second equation, it's 2x minus 3y, but it's no longer going to be y. I'm plugging in for y. So instead of 3y, it's 3 times x plus 5 equals the negative 13. So it's the same equation as what we originally had here, except that I replaced y with what the first equation said that y equaled. Having done that, it's now a matter of just solving that equation for x. And so to solve this, the very first thing we do is distribute. If you're going to run into any trouble in solving this, it's usually in the distributive part here. Because what am I actually multiplying into the parentheses? Negative 3. Yes, it's the negative 3 here. All right, so 2x unchanged. Now I do negative 3 times x, that's minus 3x. Then I do negative 3 times 5, so it's minus 15. Equals negative 13 still, because I haven't touched that. So that negative 15, if something's going to trip you up on this problem, it's probably that. All right, now we can go ahead and combine like terms on the left. 2 minus 3x, that's a negative x minus 15 equals a negative 13. I add 15 to both sides, add 15, and we have negative x equals a positive 2. And if a negative x equals positive 2, what does x equal? Yep, negative 2. Now, technically speaking, what are we doing to both sides? We are dividing both sides by negative 1 there in order to make that happen. Now remember, this is not my whole answer. My answer is both the x and the y coordinate. So I know that it's going to be negative 2 comma something. I now need to figure out what the y coordinate is. I can find that by plugging this x value back into either equation. Now in this case, one of them definitely looks like it's going to be easier than the other to plug into. I want to plug it into that first one, because I want to know what y equals, and that one is set up to be y equals. So I'm going to go x minus 5, so that's going to be negative 2 plus 5 equals y. So all I'm doing is plugging this x value in for x in that first equation. And when I do that, then I end up with 3 equals y, and therefore I know that my solution is at negative 2, 3. And again, remembering what a solution means, that is the point that is included in both equations. If I were graphing them, that would be where they would be crossing. It means the exact same thing when we do it by graphing it or by doing it with the algebra. So you should kind of have the hang of this. Work it out first and then check against the work up here. So I'm going to take what x equals and I'm going to plug it in for x in the other equation. So this is going into the other equation. It's 8 times 10 minus 3y plus 5y equals 4. All right. Combine like terms. All right, so in this case, the very first thing we found was actually the y value. We found that y was 4, but we still proceed from there to find x the same way. We still are going to take that value and plug it into one of the original equations. And I definitely think the second equation is easier here, because if I want to know what x equals, I can go to the equation that says what x equals. So I go x equals 10 minus 3, plug in our value for y. When you do that, you find that x equals -2, and there is our solution, -2, 4.